Okay, this video presentation is all about changing the subject and rearranging equations. Possibly one of the most useful skills you will have in mathematics, and one you'll certainly use in other subjects. Physics is an obvious example, but anything where there's a high mathematical content where you have to learn formula, this is a very important technique. It will save you an awful lot of learning if you understand how to do this. So what became obvious with the trig is that when we had, say, a sine, a cos or a tan, and we had to find, say, the hypotenuse, or in the case of the tan, the adjacent, which was the denominator in the fraction, well, all hell broke loose and you had no idea what to do, or a number of you didn't. And about half the class did and half the class didn't. So I'm going to go over this because it will benefit everybody. So I'm going to ask you to stop the video now and have a go at these. Right, I'm assuming you've stopped the video now. So the idea behind this is you're aiming to isolate the x. So the first thing I'm going to do, and I have a choice of things to do, but I don't particularly like negative numbers, so I'm going to get rid of the minus 2. So if I add plus 2 to both sides, the minus 2 disappears off the left-hand side and I'm left with 5x. Then I'm going to subtract 3x from both sides, which leaves me with 2x equals 5. Divide by 2, x is 5 divided by 2, x is 2.5. If this was an A-level question, we'd stop at 5 divided by 2. But because we're doing GCSE, we have to do the extra line. A bit daft if you ask me, but there we are. So here's something a little bit harder. Now, our aim is to isolate the x, but we need to get rid of the fraction first because it frees that 2x plus 7 expression, because that dividing by 3 is dividing everything. So the first thing I'm going to do is multiply both sides by 3. So on one side that effectively loses the 3, and on the other side the 9 turns to 27 because 9 3s are 27. I'm then going to subtract 7 from both sides, which leaves me 2x equals 20. And then divide by 2, x is 10. So again, fairly straightforward, a technique I expect you can do. And the last one looks a bit scarier because it's got an x squared. So the first thing I'm going to do is isolate the x term, the 3x squared term, by removing the 5. I'm going to take 5 from both sides. So 3x squared must be 147. Then I'm going to divide by 3. So if I divide 3x squared by 3, I'm left with x squared. 147 divided by 3 is 49. And then I'm going to square root both sides, and x is 7. And technically x is plus or minus 7, because obviously when we square root there is a minus 7 times minus 7 is 49, so there's two possible answers. So when you come to solving equations, you need to imagine the x is stuck inside a prison and we gradually have to undo things around it before it can be released. So you undo the last thing done to the x on each set step by doing the opposite. So if we've got the square root of 2x minus 5 is 3, then we can't add 5 because it's trapped inside the square root, but we can square to get rid of the square root. So if I square, I have to square both sides. Now I can add 5 to both sides, which effectively loses that 5, and then I can divide by 2. So give you a few seconds to test your understanding. Off you go with these. So pause the video and I'll put up the answers. So changing the subject of a formula. The formula used to calculate temperature in Fahrenheit if we have the temperature in Celsius is this formula here. The subject of the formula is the variable that appears on its own side of the equation, usually the left, and not on the other side. But what if we wanted the temperature in Fahrenheit and we want to convert it to Celsius? Well, either we have to look up a new thing in a book, or go on the internet and waste our time and find a computer that's on and working and some all the problems you're going to have. Or you can just take that formula and rearrange it, which will be much faster. And of course in an exam, if you're given a formula like that and you cannot rearrange it, you can be guaranteed they'll be wanting the formula in Celsius, not in Fahrenheit. So we're going to make x the subject of the formula. We're going to undo the last thing to get the subject each time. So here we're going to add 2 to each side. So x is y plus 2, and you'll notice I tend to put the x on the left hand side. It doesn't really matter which way round it goes, but that's just convention. Here I'm going to take off the 2, then divide by 3. Here I'm going to take 1 from each side and then square each side. Here my problem is my denominator, and I'm going to multiply the y by 4 and then add a to each side, which will give me in terms of x squared, and then I'm going to square root and say plus or minus. So this is undoing to unlock. So would you have a try at the following 5? So this is exactly the same skill all over again. When the subject is within the first argument of subtraction, it's easy to release. I've got 2x minus 3, I just add 3 to each side. So 2x is y plus 3. And then I can divide both sides by 2 to find out what x is. However, this is a little bit harder if the subject is the term being subtracted. So what I do is I add that to both sides. So now I've got y plus 2x equals 3. It doesn't feel I've done anything useful, but actually I've got rid of a negative term, which always makes me feel a bit more confident. And then I just take y from both sides, so 2x is 3 minus y. I haven't finished because that whole 3 minus y needs to be divided by 2, but you'll notice that I've unlocked the x term. So I've got 3 of these examples. Give yourself a minute or so, stop the video, have a go. So we can see how I've done them here. I've added x to both sides, so x is b plus x, and then I've taken b from both sides and also rearranged it to make x the sort of leading part of the equation. So here I've added bx to both sides, then I've taken off c, then I've divided by b, and I've got x is 1 minus c over b. This one, oh, definitely looks a bit nasty because I've got the square root of x, so I know eventually something's going to have to be squared. So what I'm going to do is AB is y plus 1 plus c square root of x. Then I'm going to get rid of the y plus 1, so I need to subtract that from both sides. So AB minus y plus y minus 1 is c, the square root of x. Now I'm going to divide by c. I've still got it in square root form, now I've got to square it. Now that is definitely a grade 6 question at GCSE. If you can do that without too much trouble, you're doing well. And again, I've got 5 questions for you to try. They are on a separate worksheet, so there will be about 20 questions, and I've got a feeling it's 19 actually. So, skill 3, subject trapped in a denominator. So this is what was causing you trouble. When the subject is in the numerator of a fraction, it's easy to release because x is just qy. You just multiply both sides by q and it's easy to find it. But it's a bit harder if the subject is in the denominator. So the first thing we do is, your instinct should be to multiply both sides by the denominator. And in multiplying the q divided by x plus 1, you are left with q. And on the other side, you've got y times bracket x plus 1. Now, what you're going to do next is you're going to divide both sides by y, which leaves me that x plus 1 is q divided by y. X is q divided by y, take away 1. So you can see this is quite a bit harder, and we will do a lot more of these next year, don't worry. So, isolate the fraction on one side of the equation, then multiply by the denominator. So here we've got b minus c over a. Here we need to get rid of that b first, so x. So remember, the x now multiplies everything on that side, so it has to go into a bracket, and then we can just take the bracket down and divide. And here we've got the last one here. So here we've got slightly more complicated. So again, this is going a bit further than you went before. So what we do, cross multiply. So basically one side's multiplied by D, one's by B. So make x the subject. If I cross multiply, I've got x, a plus 1 is bc, and then I just divide by a plus 1. And what you've got to do is not be frightened of that bracket saying a plus 1. I just think if that's x times a blob or x times a bracket. Bracket, blob, all begins with B really, doesn't it? Then I can take my blob to the other side. If it's multiplying on that side, I want to get rid of it, so I need to do the opposite, which is divide. If I divide both sides by the blob, then the blob disappears off the x side and divides on the other side. So here, I'm going to have d times b squared c x minus 1. So here, I treat my x minus 1 as one unit and move it and multiply both sides by x minus 1, so I get c times brackets x minus 1. If I multiply both sides by d, the d disappears from dividing the c and appears on the other side to multiply the b squared. So now all I've got to do is divide by this c, and that gets rid of the c on this side effectively. Dividing both sides by c, I'm left with x minus 1, add 1 to each side and I'm left with this. Looks horrendous, but when you can do it, these are really easy, and this skill builds into solving equations, which means a huge amount of maths becomes a lot easier. And it also means things like physics. In physics, you have to learn formulas like V equals U plus AT and things like that, or no, half AT squared. And you have to learn them, and it's no good if you're asked to find U. If you've got a formula in the wrong way, they won't necessarily give you a different sort of look at the formula. So I've got 9 questions for you to try there. And what I want you to do is I want to see fully worked solutions. I don't just want to see x equals. Sometimes you'll get there, some of you will get there very quickly with these. But I do want to see, perhaps, but certainly with the majority of you, fully worked solutions. Thank you.